Okay, for problem 16, I guess, what is the area between the curves? Y equals e to the x, y equals blah, blah, blah. So we're going to use your graphing calculator to evaluate. And it's important that probably this is the only problem on the exam that I'm going to say requires the use of a calculator. All right, and the reason for that, the point of intersection are pretty difficult. So what I want to do is I'm going to go to Sage again. I'm going to clear the screen. And the first thing I'd probably do if I were doing this problem over here is just get a ballpark idea of what this thing looks like. So I'm seeing e to the x. It's pretty easy to graph that, right? And the other thing is, y equals, let's plot it out. Plot. I'm going to plot e to the x. I'm going to plot two things. I'm going to put in this set notation, e to the x. And I'm going to plot out, let's see, 5 minus x squared. Now when I do this, you might be surprised that you may not get a picture you want. We can always change it. And I got a picture I didn't want. So what I want to do is I want to go back and to my, close this out. I don't want that picture. It's not helping me at all. So I'm going to hit the up arrow. And what I'm going to do is I'm going to say x min now equals, I'm going to say minus 3. And I'm going to say x max equals 3. So I'm getting a bigger view of it. I get a bigger view now. So someone says, why'd you do that? I think I know what the region they want now. They want the region between the green curve and the blue curve. You should know the blue curve is e to the x, and the green curve is that a parabola that opens downward, vertex at 5. What I want to do is find a point of intersection. And looking at it, I'm going to say the point of intersection occurs between 1 and 2. Right? The other one occurs between, I'm going to say minus 3 and minus 2. Right? So I'm going to try to go back to my Sage. I'm going to say reset. And what I'm going to do, I'm done with the picture taking. I'm going to find my the function. I want to find the roots of it, f of x. And where they intersect is where they're equal. And really what I do is setting those two functions equal to one another. So I'm going to say, 5 minus x squared. Let's see, minus e to the x. Okay? And what I want to do is I want to do the lower limit. And I'm going to say a is my lower limit. And what's my lower limit going to be? I don't know, but I know where it is approximately. So I'm going to use a command called find root of f of x. And I need to give it a bound. Right? So I'm going to say it occurs, looking at the picture, between minus 3 and minus 2. All right. Now someone says, I wonder what a is. I'm going to display a for you. A is that number there. All right. I'm also going to do b. And b equals, I'm going to say find root. And looking at it, I'm going to say the root, it looks like between 1 and 2. Right? I'm using integers. You can use decimals if you want. But I'm saying, it's somewhere between 1 and 2. And that's b for me. I'm going to display b for you as well. What's b? It's 1.24. Blah, blah, blah. What I'm going to do now is I'm going to integrate. And I'm going to integrate, let me see. I'm a pretty slow typist, aren't I? I am going to integrate f of x with respect to x, and I'm going to go from a to b. All right? Let's see what happens. And what do I get? I get a number there. I get 9.67, blah, blah, blah. I want to point out, I did use a computer to do this over here. I did not do that by hand. Could you integrate this guy? Of course you can integrate the guy. The problem is, it's the points of intersection are so difficult to come up with. There are many ways to do it, but software is one really nice way to do it. I do encourage you to do that. All right, and you'll get the number that we're getting here. Thank you.